working for CSRO. And today, the first speaker we have for the session is Tomasz. He's a Python and JS developer from Canva. And today, he'll be telling us about GraphQL, how to make clients enjoy using your API. So please welcome Tomasz.
So I thought I would have to introduce myself, but I don't need anymore. Here's a slide about me, but I won't go into it because we don't have that much time. So let's just jump to the topic. Let's see how your usual web application can look like. And all of my examples will be based on web applications because I'm a web developer myself. So at the very bottom of the complexity ladder, there is a very straightforward web application, which is just a server component that renders the application on the server and sends it to the browser. Nothing complicated, no JavaScript. And as you can see, there is really no communication between components in here because it's just a single component. Going up the ladder, there is a very natural split between front-end and back-end. And here, front-end is considered as a separate application. It manages its own data. It has to fetch this data from a server. Sometimes it makes a lot of sense to split your backend into several components. And this is called services architecture or microservices architecture. And this approach gained a lot of popularity during the past few years. But nowadays, it makes very little sense to just push your application to production on just one platform. Usually you see a trio of iOS application, Android application, and web application. And of course, we can't forget about some kind of an admin panel, management system, back office system, however you want to call it. As you can see, there may be a lot of things going on here. We have in this particular example, we have 4 backend services and several front-end clients. So where's the issue? First of all, single client makes way too many requests. Apart from obvious things like network latency, there is also an overhead in terms of protocol use. So for example, if you're using HTTP, with each consequent request, you have to send all the headers, all the cookies, which may add a couple of kilobytes to your request. Moreover, clients also are limited. So for example, your web browser has a limiter on telling it how many simultaneous connections to a single server it may be making. So real-life scenario, sort of, may look like this. Assuming that we have a single client and 3 services it has to communicate with, and the business requirement, show list of auctions for a user. So we have our service, user service, and auction service, pretty straightforward. And the first request, as you probably guessed, goes to the our service to see whether our access token is still valid. We get a response, yay, we can proceed. And then another request goes to the user service to get user's profile because we want to show the user's name, user's avatar in the top of our application. And sequentially or simultaneously, we also want to load a list of auctions from different services because that's how it was designed. We get the list of auctions, but then there was a business requirement added later that all of the auctions should also display avatars of the user that added this auction to the system. And for some reason, the avatars are stored in the user service and not auction service, and they are separated. They don't communicate directly. So client has to send this many queries to the user service. Moreover, there are differences, minor and major, between clients. So iOS and Android apps are both mobile apps, but they may need different things. So iOS, for example, may need an avatar of the user in a high resolution because of its Retina display. Android may not need the high resolution avatar, but it uses some kind of some Google API, and it needs some kind of an ID for it. Web service, web application, and the back panel, which most probably also will be a web application, usually just load everything they have, everything you have in the database, and show it on the page. There are also technology barriers we mustn't forget about. So assuming that there is this one legacy service that was written when XML was still a thing, like 15 years ago, our iOS and Android mobile apps will have a very hard time communicating with it and preparing XML requests and transforming XML response. On top of that, there is way too much knowledge for a single client to know where each of the service is. And adding new service will make you, as a developer, update all of the clients to, well, to add its URL, add a way how the client should talk to the service. And pretty soon, you figure out you need something in between. This component in between, this component in the middle, is maybe called a gateway or a reverse proxy. That depends on what it does. And this is actually a good thing to introduce to architecture like we used, for example, because this is a single point of contact for all the clients. So right now they just have to call one service and use one protocol to talk to it. So most likely it will be HTTP and it will be JSON over HTTP. Gateway may also translate the requests and responses from the client and vice versa. So for example, client may say JSON request to the gateway. Gateway will then translate it into an XML request to a legacy service, and the other way around. But there are some things we have to consider. First of all, the gateway, which will be a separate component in our architecture, is another place where you have to maintain the schema. Ideally, there should be only one place to have the schema defined. Moreover, there will be a slight network overhead. So assuming that your gateway and your services will live in the same network infrastructure, this will be just a couple of milliseconds. But if you multiply that by tens of thousands of users, then it quickly adds up. This is the same when we speak about the performance of the gateway. You won't see this on a local host because it will be very fast. But gateway has to be blazing fast in order to serve a lot of users. And the worst thing, in my opinion, is that the gateway is a perfect place. Well, it's not a perfect place, but it's very easy to start adding some logic to the gateway, which shouldn't touch data at all when you're using a services architecture, because for example, there might be a deadline or some business requirement, and it would be much easier to just query modify the data in the database directly from the gateway rather than calling a service, adding an endpoint, and so on. So as I just said, properly creating and more importantly, properly maintaining the gateway is a very hard task. How to make it easier? You probably guess what my answer will be. It will be the GraphQL. It was presented by Facebook, I think it was 2 years ago, but they claim to have used it internally since 2012. Gateway fits between your clients and your backend services. So what exactly is a GraphQL? Unfortunately, GraphQL is not an API server, nor is it a gateway implementation. Sorry. GraphQL is something different. It's a query language and a schema for your API. Here's in very short 4-point list arguments why it might be for you. Let's go through them. First of all, and this I think is the most important thing, GraphQL is declarative, and most of you probably know another language which is declarative. That's SQL, where you just specify what data you need, and you don't really care about how the database will process the data to generate the result in most of the cases. GraphQL is also very good at hiding the implementation of the services behind it, because when you're talking to GraphQL server, you're using GraphQL query language, you're using GraphQL schema, but you have no idea what's behind it. On top of that, GraphQL, by being a framework and language agnostic, doesn't enforce any best implementation and any default behavior, and doesn't really care whether your data comes from a database or from remote API or is computed in place. It just needs something to provide data and doesn't specify what it is. The next one is being explicit. So first of all, there's a strong, the schema and queries are strongly typed. Moreover, client has to explicitly ask for a field to receive it. So you can, for example, extend your schema without affecting any older clients at all. And there is also one concept behind GraphQL, which is to query, to request for all the data your application needs in a single query, in a single network request. And And this is more important for users with a very slow connection. So let's assume that there is a user for your application in the middle of Australia with an Edge or GPS connection, and then each kilobyte really matters. Engineers at Facebook, maybe it wasn't at Facebook, but it goes like this. Most of the pages and most of the applications work this way. First of all, display a spinner and placeholders, then send a network request and load all of the data, hide the spinners and placeholders, and that's when the user can start using the app. And this is here you can see it maybe more obvious on this schema. You can see that single request to the gateway may take 2 seconds. Then the gateway quickly gathers all the required data to serve this request and returns just a single response. If our client had to communicate with gateway for each of the requests for the services, which means if our gateway was just a reverse proxy and not a slightly more intelligent gateway, this would take much more time. OK, so now is the time. Now is the time when I click. When I try to show you how querying in GraphQL works. So together with GraphQL, there is a tool called GraphQL. Can everyone see the screen and read it? I think I can, yeah. There is a tool called GraphQL, which is, first of all, a query sender, as well as a schema explorer. So if you will be using GraphQL, for example, after this talk, you can quickly explore any schema in any API using this tool. So here's a very simple query. We just want a user with ID 1 and get its first name and last name. And there you go. What about extending the query? As I said, GraphQL doesn't return any fields unless client explicitly asks for them. So let's ask maybe for email of this user and maybe how many bets they placed. And our example is based on an online betting application. So we have types like user, but also there is a bet. Bet is connected to an event, and event is connected to a sport. So let's try running this. As you can see that, well, GraphQL doesn't have any issues with returning fields in the same for the same model. But what if we wanted to do something more complex? So as I said, user places bets. So user should be in our schema. User is connected to a bet. So it is very easy to just get all related data to the user. For example, the bet. So for each bet, for all the bets that the user placed, we also want the amount of the bet placed, the amount of money. And you can see that it is displayed here. And the great thing is that for GraphQL, it doesn't really matter whether this data comes from the same service or from a different service or from remote API or from database. It will be shown later. It just happens. For the client just sends a single query specifying all the requirements, all the data they need. And GraphQL's job is to provide all this data. So let's go further. As I said, bet is connected to an event. So we can easily query for the event name. And there you go. You can see that queries to GraphQL, you can see that there's a relation between query to the GraphQL and the response, where response is just the JSON. So please omit the data for now. Just look at this part. Query is just the JSON returned. The response is just the JSON. And query actually looks like a JSON, but without the values, with just the keys. That makes it very easy to compare what server returns for which query, because you just take the keys and ask the server, OK, here are my keys, give me the data. One more fancy thing that I will show you is how to pass arguments to the fields. So let's say that one of the users, I think it was the user number 2, has too many bets, and we don't want all of them. It's very easy to specify arguments. For example, we just want his 5 bets to be displayed. And the place where this really shines is that for fields, we can specify any modifiers. So for example, the amount here is presented in US dollars, but what if we wanted to display amount in euro? We can just specify, OK, give me the amount, but I want it in euro. And GraphQL doesn't have any issues with converting it on the fly. And before I go back to the presentation, I will also show you one more thing. So these are GraphQL queries. And if you translated that to the HTTP, this would be a GET request. GraphQL also has a concept of mutation, which is a POST request, something similar to a POST request. So here we have a mutation to actually add a user, where you specify the payload, and also specify what do you really need, what do you want in the response, because in GraphQL mutations are also typed. The payload is typed, as well as the mutation has to specify what exactly it will return. So we want to add this user and get the ID of the added user just to see whether it worked. So you can see that the request was successful. And then if I, for example, specify, going with our example that we want to show we want to show more specific information about the current user and some not as specific information about other users, we can, in the single request, query for all the users and get there, for example, I think, yes, there's an avatar. And the avatar may also be kept on a different service. It may be kept just somewhere else. When I execute this, you can see, this the user that we just added doesn't have the avatar, so it failed. And you can see that we have everything about our user, as well as the all users entry, and the entries here are their avatars. OK, so let's go back to our slides. Whoops. OK, that didn't work. To summarize what I just showed you, client gets only what it explicitly asks for. If there is a need for the client to get additional piece of data that already is in the schema, then it's very easy to query for it. You don't need to modify any endpoints on the backend. That's, of course, assuming that your schema is properly constructed. The only thing that you need to add is an additional key in your query, and GraphQL should resolve it in a very good way. So here was a slide about mutations that I just showed you. So what exactly is GraphQL schema? GraphQL itself is only about the schema and not actual implementation. This is similar to how what SQL is to the databases. So there's a SQL standard. The current one is, I think, SQL 2016. And there are actual SQL implementations in the databases. This is how schema looks like. You can see that there are some simple types like string, int. There's also float and boolean, and ID, which is string underneath. And you can see that types, which are our, let's consider them to be our models. Types can reference each other. So we have a type user avatar, which is then used as a return value in a type user. So the first name, for example, it will be the name of the field. And the string is what GraphQL expects our API to expects to return. Is expected to return. Lists are you can see that for a bets field we return brackets with bet inside. This is how GraphQL schema defines a list. And if you worry about exclamation mark, it's just a way of making a field nullable or non-nullable. There are the other fields there are the other types that we have inside our schema. So there is a sport. Sport has a list of events and a list of bets. event has a reference to sport and list of bets, and bet just references user, bet, and sport. At the top of our GraphQL schema, there is something called root query. Root query is just another type where it specifies the name of the entry point and what this entry point returns. So previously, I used the all users to get the all users avatars. There isn't any real difference between this type and user type, for example, other than by convention naming it query, as well using it in a schema below. One good thing, one thing worth of noting here also is how GraphQL, it's easy to extend your API, extend your schema in GraphQL. So GraphQL advises you not to remove any fields from the schema because some clients may use it. Instead, you can use a deprecated decorator, which will tell all new clients that would want to add this field to a schema. They will just get a warning. So this field is deprecated. Just make sure what you're doing. And you can see that we in pretty easy way converted avatar URL into the avatar just added avatar structure to the user. There are much more advanced topics about GraphQL. I won't be able to cover all of them during this talk. If you want to learn more, there is an official GraphQL tutorial at graphql.org, and there is also the official specification of the language. Okay, so I've been talking about GraphQL, but how to do this in Python? GraphQL implementations exist in multiple languages. Python is obviously not an exception. So this is a schema done using a graphene library. As you can see, it is pretty straightforward. It maps in a pretty straightforward way to the schema which we saw previously. This is how the root query is constructed. So also nothing really different. Graphene expects that you will provide it somehow the schema object, which is the graphene schema, which is an instance of a graphene schema. One very important concept to GraphQL, I didn't talk about this before, are the resolvers, because you may wonder right now, okay, so GraphQL is cool, but where the data comes from? It's all due to resolvers. So resolver is a function that provides a value for a single field. It's just that, only that, but by using that, it doesn't really care about where the data comes from. So as I said previously, it may come from a dict, it may come from a remote API, it may come from a database. In our example with using GraphQL as a database, it would probably come from a service that sits behind the gateway. Here is an example of how to get the data for users from some cache implementation, or to send a request to the appropriate service and unpack it. We can also use external, very easily use external entity, for example, to convert currency between USD and euro. And the most important thing here is that client will be totally oblivious of what's happening. So this will all happen behind the scenes. Client will just say, give me currency, give me the amount, and I want it in euro rather than USD. Done. Graphene is also capable of resolving the fields simultaneously. So here are a couple of executors. The default one is sync executor. But if you want to parallelize the execution, so for each requested field, appropriate resolver will be called. So you may want to use async IO executor or thread executor, for example. If you're using Django, this isn't really relevant to the gateway example, but if you're using Django, there are some batteries included. Assuming that we have models like this, very simple models, our schema will look just like that. Graphene, or actually Graphene Django, will take care of converting the models into GraphQL schema and also making sure that the references are there. The only thing that you will have to write yourself is the resolver for the entry point. So here we just get all the users from our database, which in fact are Django objects, and they are under the scenes. Behind the scene converted into Graphene objects. The same happens for SQL Alchemy. So assuming that we have these models, we can do the schema in exactly the same way as for Django. There is much more to GraphQL than I just showed you. Of course, there's an awesome GraphQL list. There are several servers and client libraries available. I think the place where most of the GraphQL development happens right now is JavaScript. And that is because, together with GraphQL, Facebook released a client library called Relay, which is used to couple your React application together with a GraphQL server. But if you're not using React, then that's not a problem. First of all, the new version of Relay, from what I heard, is also framework agnostic. And there's also Apollo, which doesn't really care about whether you use any framework or not. OK, to summarize, because I have 4 minutes left, GraphQL is cool. What I really like about GraphQL is that it promotes really nice things without really enforcing any particular behavior or implementation. If you're in the middle of creating a gateway for a project or you're considering something similar, try GraphQL, because it will for sure make life of your developers or yourself, and especially the client developers, much easier. This is also a good way to keep your API clean, consistent, and organized. But there's a caveat. You might not need GraphQL at all. So don't treat GraphQL as some shiny, magical hammer that will make all your problems go away. Unfortunately, GraphQL is a relatively new technology, and the adoption is really small right now. So there aren't that many resources online available. Moreover, if you're making a small project, you may be, well, if your project is really small, then you may consider using fancy things like GraphQL at all, especially if you're doing a startup. So my advice here would be just go with the most boring piece of technology that you can find, and first succeed in business, and then worry about, when you have millions of users, then worry about using GraphQL, for example, rather than a simple REST API. And that's it. So I think we have 3 minutes left for questions. So if there are any questions, I will happily answer them.
OK.
I just want to ask that to what kind of level that my backend need to use that GraphQL?
To communicate with other services?
In terms of the complexity and the number of users? To what kind of degree we need to implement that?
So that really depends. I mean, I only talk about considering not using GraphQL at all because I've been in a couple of projects that had really high expectations in terms of how many users they will have. And after 6 months, it turned out that the solution was really over-engineered when compared to the real traffic. So GraphQL is a really nice addition if you already have established services in place. But it might not be, well, the service or microservice architecture might not be very good if you're just starting. My advice is start with monolith. And only then, if you gain more traffic, if you encounter real problems, for example, the performance problems, only then split them into services, and only then start worrying whether you need gateway at all. So this is more viable for projects that already have something in place or know that they will have traffic, they will have users, they will have performance issues, they will have bottlenecks, and they will have, for example, several clients that will have to somehow share the schema.
Any other questions? No, OK. Sorry, I didn't see yours next.
One nice thing about sort of using REST APIs is being able to use like Postman or curl or something to just quickly have a look at what's going on. Using just the command line or a simple tool, how do you like to debug and inspect GraphQL endpoints?
So underneath, what GraphQL is also by convention, is that it sends a post request to /GraphQL endpoint. And the payload is, I think it's just a query, just a JSON with query being a string. and the response is just JSON. So you don't need to use any tool for it. I think I think you will be better off with using a library for it. But if you want to investigate the query, for example, I don't think that you will need much more than what you already use. 15 seconds left. Any other questions? Yeah.
Thanks for a good talk. So your example sort of story was you've got your sort of vanilla REST API and you put the GraphQL in front of it. Is it worthwhile for those backend servers to be, GraphQL themselves? Does that make any sense or not make sense?
I can't answer this question really well because in the project where we used GraphQL, we started using GraphQL also on the backend for the service to communicate. So the rule was for each request from service to go through the gateway. That didn't turn very well because there were some issues together with it. So my best answer will be that you have to consider all the pros and cons of this. The service itself doesn't have to have anything fancy. If it's separated, if it doesn't have to get data from anywhere else in your system, then it can be just a REST API.
Okay, can we all thank Tomasz? And